Hello, this is the LP3 assignment for Advanced Project Management, National American University, and my name is Brad Morgan. To answer these questions, I'm going to go one by one, and I will pause in between for the answers. Yes, R&D can be very expensive, and in this case, the 7 failed projects resulted in about $24 million in expenditures, which is only slightly less than the original budget of $28 million. Moreover, if the company is not as large and established, the result of these kinds of failures can bankrupt a business. As Dale Carnegie stated in How to Win Friends and Influence People, typically only 1 in 10 people will admit that they were wrong. People do not like to admit fault, and it can be natural for individuals to pass the blame onto others. In an environment of open communication and free of fear and persecution, candid conversations can occur rather than pointing fingers. Conversely, in an environment of fear, people will quickly blame others, quickly blame on a scapegoat. The first step to avoiding this is to facilitate a proper type of environment, as mentioned. Exhibit 1 shows the failure identification per life cycle phase. One can see that in all projects, strong resources, or at least average, were used. It also shows that the failure identification comes in the last 2/5 of the project, at the very end. Exhibit 1 does not go into detail as to what each phase is, nor does it answer what caused the failure. Overall, it's very generic and it fails to give quality information about the situation surrounding each failure. It is possible that individuals can overthink solutions, although it is counterintuitive, as one would most likely desire to choose a path that is going to lead to a simple solution. As mentioned by one employee, engineers may have the desire to do their best and obtain optimal results, but this may not be in the best interest of the company. The second question, there is not much to say about this. 5 out of 12 is abysmal. In addition, they stated that the successful projects did not turn out to be the shining stars that they were expected to be. A company cannot achieve greatness with a 42% success rate. No, a PMO cannot prevent failure. However, it can do its best to mitigate risks, refine processes, and develop methodologies to improve the likelihood of success. I would say no. This is a good responsibility and capability for project managers to have. Seasoned project managers can usually identify unrealistic expectations or identify when things may not turn out as expected, although this may not be the right capability to assign to a junior project manager or somebody who's new to the field. It is possible. The engineers that I know tend to be perfectionists. However, that is kind of stereotyping in my opinion and may not be realistic. That is a good question. I somewhat disagree. Good metrics lead to better decision making, but I would argue that also without good metrics, it is difficult to identify the root cause of the project failure. Therefore, the company should implement the new project management metrics, then evaluate the result of the next project and see if there are any other potential causes for the project failure. The PMO taking the lead in establishing the project management metrics makes sense if the PMO is made up of seasoned project managers and individuals who are good with numbers. A few days should be enough time for individuals to prepare ideas and to get the ball rolling. This makes sense for an initial meeting, and it would be assumed that there are several other subsequent meetings. Executives should not attend but receive a briefing of the meeting. People tend to behave differently when they are quote-unquote being watched. particularly when it's by executives. Not having the executives at the meeting will better allow for ideas to be shared more openly. Part 2. Yes, simply put, because changes for the better can be made based on information gathered. No, the makeup of the team does not seem correct. When creating project management metrics, it would make the most sense to involve individuals who are experts in project management. Project managers, for example, specifically seasoned project managers, and preferably with PMP certifications. Research and development and the PMO leader are two of the best choices in my opinion, but marketing may not be the best choice. Also, engineering and manufacturing might be a good idea, but involving more senior project managers would be the best. Yes, it may seem that way to some. It is important that the purpose of the metrics be explained well and potentially involve the individuals who are going to be measured or using the metrics to help come up with ideas. This helps gain buy-in and reduces resistance. Yes, they are very appropriate. However, one great question to add in is how responsive are these metrics? Or how responsive can these metrics be, rather? As mentioned in Exhibit 1, the metrics need to be reported in real time. A lag does not do anyone any good. The purpose of these metrics is to help the project managers determine if the feasibility of the project early on and detect any critical flaws. Earned Value Management, EVM, would be at the top of the list. It does a great job of monitoring the triple constraints of scope, time, and cost. It is a great indicator if something is going seriously wrong and allows the project manager to course correct or abort the project if necessary. Part 3. The risks are the high costs in terms of the money used in gathering the data and having too much information that makes it harder to decipher. Not having enough information to make an informed decision, staying in the same predicament that the company is already in, and possibly looking better or worse than it actually is. Quantitative metrics include metrics such as percent of work packages adhering to schedule and budget and cost variance, and percent of actual versus plan baselines to determine to date. Practical metrics include metrics like customer satisfaction rating, improved efficiencies, assigned resources versus planned resources, directional metrics, project complexity factors, schedule performance index, the percentage of work packages with critical risk designation. Actionable metrics include the number of unstaffed hours. Financial metrics include profit margin, return on investment, net operating margin, and potentially cost variance. Milestone metrics include the number of packages on time, percentage of actual versus planned baselines completed to date, and schedule and performance indexes. The end result or success metrics include customer satisfaction, percentage of packages adhering to schedule, and percentage of packages adhering to budget. Part 4. I agree with the statement that all KPIs are metrics, but not all metrics are KPIs, and that KPIs are critical metrics that say something and can be used in decision making. A simple way to tell is by utilizing criteria such as in Exhibit 1. They should be predictive, measurable, actionable, relevant, and automated. The biggest consideration should be the impact of the quantity of KPIs. There should be enough KPIs for decision makers to make solid, well-informed decisions, but not too many because it can be distracting, costly, and even a bit convoluted. Overall, about half of the metrics could reasonably be considered KPIs. The most common aspect that's missing from the non-KPI metrics is the category of predictive and automated. Some of these metrics cannot show what is to come, and some of these metrics are objective and cannot be automated. Part 5. Per one of the 6 main characteristics of KPIs, they should be measurable. If it's not measurable in some quantitative way, it's not a true KPI based on this characteristic. However, qualitative data can, at times, be converted into quantitative data. However, this is objective and can be inaccurate. It is important to keep in mind that KPIs are not targets. The exhibit should work well for a measurement tool to signal the need for attention. However, as stated in the case, some projects may require slightly different amounts of variance. For one project, executives might be okay with plus or minus 10%, while another project or an aspect of the same project may only want to allow 5% variance. One way to address this would be to incorporate establishing the permissible variance in the onset of the project when the charter is established. Part 6. One suggestion is to create ranges for the weighting factors and set a nominal weight value. That way, there is some consistency in the weighting values for each component, but there is flexibility for the project manager and key stakeholder in determining what is most important for that specific project. I would say it should be weighted more towards what the customer wants. On the other side of the coin, the contractor is, or at least should be, an expert at what is being done and knows their team capabilities. Therefore, contractors should have a strong say as well, or be in a position to voice any potential concerns. Yes, the value component can change over the life cycle phase. A couple examples of appropriate circumstances are when the project is running over schedule or budget. At that point, it's a good idea to put some extra emphasis on those aspects. Using criteria in the case study, it should be when the value contribution total is well under the average, 2.0. When it is under the average, the project manager should make an assessment as to what can be corrected to remedy the situation, and if the situation can indeed be fixed. When the variance can be corrected, if all categories are at least meeting expectations and one is falling short, then a project manager can assess the situation and see what can be done to fix the situation. Another case where the project should be allowed to continue would be if the category that is pulling the total below the 2.0 mark is considered to have minimal impact on the overall project. Part 7. Both approaches have disadvantages of potentially having the sponsor view failure as a sign of weakness, damage to one's reputation, or damage to one's career, thus potentially resulting in a failing project continuing on longer than it should. The first approach does have the advantage of involving key decision makers in the company who are seasoned. The second approach has the advantage of freeing up top management for important tasks, but falls short if people on the teams are not honest with lower and middle management about the progress that's being made. I would pick the first approach with the executives being part of the project from start to finish. However, I would pick either approach if the environment was such that open communication was encouraged and that people knew that canceling a project doesn't necessarily mean that they're a failure or that it would damage their reputation, and that it may be in the best interest of the company. I also really like the exit champion idea. This could be implemented in conjunction with one of the other approaches. I do not believe that this should be the case. The exit champion should evaluate all angles of the project appropriately to determine the feasibility of completing a project within a specific and reasonable variance. Part 8. In theory, a metric could be created using risk probabilities. However, no model or metric can predict success with a high degree of accuracy, particularly for innovative projects that are already hard to predict in terms of cost, quality, and timeliness. I believe that there can be a metric for predicting capacity needs. However, it may be difficult to predict capacity requirements for incomplete projects, especially in the early stages of a project, or without knowing whether a project will be a success. The biggest risk that a company faces, assuming that these metrics can be created, is that if the capacity is accurately predicted and the company initiated the capacity expansion and the project fails, not only will the company incur the costs of the failed project, but it will have excess capacity, and excess unused capacity can be costly. And that is it. Thank you.